program lead Bytes. I would like to welcome all the participants to Bytes Expert Series. I would also like to welcome today's resource person, Dinesh Rivankar, Senior Architect, Persistent Systems Limited. Today's topic is blockchain. I would like to introduce today's eminent resource person, Dinesh Rivankar. He is a senior architect in the field of information technology, graduating in the year 2006. He further pursued a master's in information technology. He has 14 years of experience in the field of information technology. Once again, I would like to welcome Dinesh Vankar, sir. I request Dinesh, sir, to continue the session.
Sure. Thanks, sir. So, hi, everyone. My name is Dinesh Rivankar. And as Bhagav had said, I belong to Persistent Systems and I work as a senior architect in Web3 space. First of all, thanks to everyone who have joined today, virtually or in presence, because you guys have reserved your 1 hour to listen to me on blockchain. So thanks again for reserving that time for me. And also thanks to the organization for organizing such event and giving me an opportunity to be out here and deliver this session. Since we are having this online session and I don't have any moderator with me, I'll take questions at the end of the session. So if you have any questions, please note it on a piece of paper, and then we'll reserve last 10 minutes, 10 or 15 minutes for those questions. And I'll try to do the justice to all the questions. Just moving ahead, let me just introduce myself. I know Bhargav sir has already done that excellently, but I'll just give you a glimpse of what I am currently. So, as I said, my name is Dinesh Rivankar. I'm part of a blockchain practice in Persistent. I graduated in 2006, did my master's in IT, that is MS in IT, and now currently I'm learning, pursuing my MBA in finance. Talking about my area of specialization, I started the career as a web developer, and now it is Web 3.0 what I'm handling for last 7 years. And having multiple expertise in the field of, say, web development, Java development, LAMP stack, mean stack, and now the blockchain. Beyond the professional say endeavor, I have been a part of many technical committees all around the globe, wherein we contribute lots towards the open source community in a blockchain space. Additionally, I'm also part of many educational societies, being on a board of studies, wherein we promote the IT infrastructure or IT subjects in a given colleges. So that's a small background about who I am, and let's not waste time and understand what do you mean by blockchain and what are different things what we are going to cover out here. Now, many times when I give this session, people always ask me, what is blockchain? And what I explain them in one sentence is blockchain is a decentralized shared data store, which is synchronized, cryptographically secure, verifiable, and tamper evident. Now, what does this mean, right? Blockchain is a decentralized. That means there is no central authority who controls the entire application of yours. Again, since it is decentralized, it is also a distributed shared data store. That means the data, what you are entering, the database where your data is getting stored, is being shared across multiple hops. So multiple people are having the copy of your data store. Now, since we say that it is multiple parties who are having your data store, it is shared across multiple, say, organizations. That means the data needs to be synchronized across all the copies of data, right? We cannot say that one record is there in, say, shared database 1, second record is there in the shared database 2. That's why we need to have the synchronization of it. Now the data is there, it has been distributed, it has been synchronized, it has been cryptographically secured. Now, what is cryptography? We are aware about something like calligraphy, right? The cursive writing and stuff. So what is cryptography? Now, cryptography is a word which has been derived from a Greek phrases, that is crypto and graphy. Now, crypto means something which you want to keep secure. Okay. And graphy is like an art of writing, right? So writing something in a secure manner so that the other person cannot read or the unauthorized person cannot read, that entire process is called as a cryptography process. So our data is cryptographically secured. Now it's cryptographically secured. That means you need to verify it every time, right? So there is a verifiability component also to add it to this. And it is a temper evident. Now, what do you mean by temper evident? There is nobody who can come and tamper with that particular data, what you have written inside. That means you can only write data to blockchain. You cannot edit or you cannot delete the content which you have written in blockchain. So in simple word, we say it as a decentralized, distributed, shared data store, synchronized across the multiple organizations, which is cryptographically secured, verifiable, and tamper evident. Now we know what blockchain does, but what is behind this blockchain as a platform? So what is the technical science or computer science behind this technology? Now I will divide it into 4 chunks. Okay, the first part is distributed system. Now, as I just said, distributed means it has been distributed to multiple parties. So multiple party have the content what you have been created for. Now, there is always a question saying that if the data has been distributed, okay, who takes the decision of it, right? Imagine there are 5 people who are planning for a holiday. All 5 come together and they say, we will plan for a trip to a hill station. Now, all 5 needs to come together and take a decision saying that whether they want to go to the hill station or they want to go to somewhere else, right? So the consensus between all this party is very important, and that is called as a distributed consensus. So in blockchain also, we have something called as distributed consensus, wherein all the participants from the network come together, they verify a transaction, saying that this is an authorized transaction or not, and then they commit this particular transaction. Now, there is a component of fault tolerance which is also required. Imagine the same 5 people come together and they say, you know what, we'll go to a hill station, we'll go on 10th of August. Now, everybody said yes, but on the day of departure, say one person pulls back, saying that, you know what, I cannot come, I never said yes to you. So how do you handle this fault, right? So to handle the fault, there are different types of algorithms which are been implemented so that even if there is a faulty node or even if there is a faulty database, the majority of them should have the correct values. Okay. And to give a simple example, a simple prototype, wherein if I say that if I want to handle, say, one faulty person, or if I want to have one faulty tolerance, then I should have n into f plus 1. Okay. So for example, if I want to handle one fault, okay, so it is going to be 2 into f, that is 2 plus 1. So that means I should have a group of 3 people, wherein one person can go faulty, but still I will have a majority, that is the 2 people saying yes to my plan. Okay. Take another example. If I want to handle 2 faults, okay, it is going to be 2 into 2, that is 2f, right? 2 into 2, that is 4 plus 1, 5. So if I want to handle 2 fault, I should be having 5 people coming together. So taking back to the same example, if there is a 5 people in a group and who says that let's go to hill station, I can still go to hill station if 2 people say that they don't want to come, or they ditch you on the last day saying that we never said that we are going to come. That's the fault tolerance. We replicate the same scenarios into the blockchain ecosystem, wherein we says that out of this 5 participants, if 2 participants are not able to verify that particular transaction and 3 of them have been verified, which is a majority, we can still commit this particular transaction. Now, as we learned earlier, it is distributed. That means the copies are being created and distributed to multiple people. So whenever there is a new record, that record also needs to be replicated to all these people. That is the replication part of it. Now let's see the second pillar of it, that is the cryptography. Okay, it's a crypto plus graphic, right? Something which I want to hide, but I want to write in a fashion that nobody can read it. Now, when we say cryptography, there are multiple things what happens out here. Whenever we create a transaction, this transaction becomes a part of a tree, and we call it as a Merkle tree. Okay. Now, just imagine a small tree. There is a root node. There are two nodes attached to it, and each two subnode have more children attached to it. So it forms like a long-lasting tree, right? So that's the Merkle tree. And how Merkle tree works is something what we are going to check in the next slide. But currently, what I will say is all your transactions are being hashed and they are being committed as one node to this particular Merkle tree. Signing. Now, whenever you create any transaction, okay, you sign that particular transaction and commit this particular transaction. Now, what is signing? For example, anytime when we walk into a government department or any non-government department also, whenever we place any request, so that can you give me my birth certificate? Can you give me approval for doing XYZ? What do? We write a long application. We sign that particular application to prove that I am the person who is writing this application and I have given the consent for administrating this particular application and giving me the required details from the application. That signing is exactly replicated in the blockchain scenario also, wherein whenever you are creating a transaction, you sign that particular transaction to prove that you are the person who has created a particular transaction, and then you send it to the blockchain network. So that's the signing. Proof of work. Proof of work is one of the consensus mechanism. Now, as we said, we have distributed decentralized ecosystem. Now, when it is distributed and decentralized, that means there is no central authority. The question what arises is who is going to take a responsibility to write this transaction into the database, right? In normal database scenarios, what we do is we create a root user, we configure that root user in your application, and whenever somebody does a transaction, the root user commits that particular transaction. But here, since it is a distributed system, there is no distributed and decentralized, there is no central authority, there is no root out here, right? That means there should be somebody elected or somebody selected who can commit this particular transaction. And this selection is done based on the consensus mechanism, to which proof of work is one type of consensus, and we will learn more about it in future. The third pillar is the networking. Now we know that we are not connecting humans to human, right? We are connecting machines to machine. And how do we connect this machine? That is the P2P networks, that is peer-to-peer network. Now, today is the world of cloud. Okay, we don't have any physical wires which are being pulled from one device to another device. But how do we communicate with the device, and how could we get confirmation saying that I'm talking to the same device with whom I'm supposed to talk to? That has been done by the communication protocol and the P2P network. Now take a simple example of three-way handshake. Okay, suppose I have two say computers. One is placed in Mumbai and the other placed in Delhi. Okay, I want to communicate with each other, right? The Mumbai laptop wants to communicate with the laptop which is kept in New Delhi. How do they communicate? There is a three-way handshake protocol. What it does is the Mumbai laptop sends a message to an address which is known to him and depicted as a say Delhi address. He sends a message to it saying that hi there. Okay, and he encrypts some details about his machine. Okay, his machine's public details, and he will encode everything by using the public key which is available of the Delhi machine. Now, when I say public keys are available for everybody, right? Just take an example. When you log into any application, say LinkedIn, right? You log in with your username and password. Your username is publicly available, and that is the way people can search you. But your password is something private to you. That is called as the private key, right? So with public nature, I could embed that entire message with his public identity and push that message to this machine. Now this machine will be able to decrypt that message only if it has the private key of that particular message, right? And private key is its own identity. So he can decrypt it and say, okay, fine, this Mumbai machine is saying hi to me. I should reply back to him saying that hi. He also replies back to it. That is the second handshake, what is happening. And once the Mumbai machine gets the reply, they send the actual message. That is the third message which goes in. So that is called as three-way handshake. So similarly, there are multiple protocols which can be used to do this networking. The last pillar is the database. Now we says that it is a distributed, decentralized ecosystem, synchronized database, right? That means the database should have some policy controls like the transaction processing, the consistency, and the linearization. Now, transaction processing, consistency, and linearization plays a very important role. Imagine a scenario if you have a 10 rupees and you want to pay two people. Okay. So you want to make a payment to person A, that is 6 rupees, and you want to make another payment to person B, which is say 5 rupees. Okay. Now the total is exceeding the budget what you have in your hand. You have 10 rupees and you want to make total payment of 11 rupees. Imagine if there is no linearization, if there is no consistency in processing those transactions, you could still create these two transactions parallelly and both will be locked on the blockchain because multiple people are validating your transactions and there was no consistency or linearization. And to avoid this type of activity, we normally call it as a double spend. What we do is we have a transaction processing mechanism wherein we maintain the consistency of the transactions and we follow the linear fashion, the transaction commission in linearization. So that means whenever you create a transaction, there is a timestamp which gets attached to your transaction and the transaction commit goes based on your timestamp. And before committing the next transaction, you will validate if he already has that particular balance or not. So these are the four main pillars which are required when we say that we are working with blockchain. So this is the computer science behind the blockchain. Now, many times people get confused with Bitcoin and blockchain. Everybody who dives into it for the first time, they always says that Bitcoin is blockchain or blockchain is Bitcoin. But the correct definition of this is Bitcoin is a blockchain-based cryptocurrency. The application is totally based on blockchain. It's not blockchain, it is based on blockchain. So in simple word, Bitcoin is a P2P electronic cash system which was put into action by an unnamed person, that is Satoshi Nakamoto. Now, what are the different things blockchain what are the different fundamentals from blockchain? What Bitcoin has used is the chain of blocks, okay? The Muckle hash tree, what we just saw, the signing, the cryptographic immutability, it is a shared ledger, proof of work, that is a consensus mechanism. And the main important point out here is incentivization. Now, since it is a decentralized distributed ecosystem, there is always a question saying that who will commit. Now that question is been answered by the consensus mechanism. But why will I commit is the next question. So whoever commits this particular transaction gets an incentive. And that is the reason why I will commit the transaction. Okay. So that's the incentivization model. Okay. Always know that Bitcoin is not blockchain and blockchain is not Bitcoin. Bitcoin is just a blockchain-based cryptocurrency. And there are 42,000 cryptocurrencies available, 4,200 cryptocurrencies available. Okay. So it's not that it's the only cryptocurrency. There are multiple cryptocurrencies which are available in the market. And we will not dive into that. We will stick to what is blockchain. Now, I have been talking about Merkle hash, okay, transaction hash or Merkle tree. What is Merkle tree? Okay. Now, imagine that a Bob wants to create a transaction. He wants to pay Alice, say, around 100 BTCs. BTC is a Bitcoin. So the transaction 0, which we can see here, is the transaction which has been created by Bob. Similarly, there will be many participants, okay, many customers who wants to create those transactions. So TX1, TX2, TX3, these are all the transactions created by the customers. Now, every transaction, we convert that transaction into hash code. Okay. So transaction 0 is converted to hash 0. Transaction 1 is converted to hash 1. And similarly, hash 2, hash 3. Now, these hashes are again combined together so that I can create a tree structure. That is hash 0, hash 1 is combined and it will create hash O1. Okay. Hash 2, 3. Now, by combining all this transaction together, okay, one by one, okay, from bottom to up, we'll get something called as a root hash. Okay. Now, when I say blockchain, okay, we always said it is a chain of blocks coming together, right? Or chain of transaction come together to form a block, and chain of block forms a blockchain. Now, this all transactions are been committed and they are kept in this entire single block. And this block has two parts. One is the block header, and the second is the block content. Now, the block content is all these transactions. The block header consists of three main components. One is the root hash, which is calculated based on all the transaction it has. We have nouns. Okay, nouns can be any pseudo random generated word. Okay, for simplicity, we can just say nouns is like a timestamp which keeps on changing every day. And the previous hash of the last block, which means I'm getting a connectivity to my last block, and then I'm forming a chain of blocks, right? Now, imagine a condition, okay? Whenever we hash something, okay, it cannot be unhashed, okay? It is different from what is encoding. When I encode something, I could decode it. But when I hash something, I cannot unhash it. Okay. So that means if somebody wants to update anything in this particular block, okay, what he needs to do is he needs to recompute hashes of all the transactions in a such a way so that the root hash doesn't change. And as we know, even if you put a single space or a single dot in any string and try to create a hash out of it, the entire hash changes. Correct? That is the reason why we always say that this is tamper evident, right? Nobody can edit or nobody can delete anything. The moment you edit or the moment you delete anything from any of these transactions which are already been committed, okay, you will change the entire tree. You will change the entire chain of all these blocks, okay, and you will create a fork. So that will be two different blockchains which we create, and that doesn't happen, and it is not that easy. Okay, that's the reason we says that we can verify your transactions. Okay, we include all the valid transactions in the block. Okay, we do this by generating a proof of work consensus mechanism, which we will see in further slides, and we confirm the transaction. So once this block has been committed, you cannot do anything to this block. You cannot tamper with this particular block. Now, when I say blockchain, we understood what is the technology behind blockchain, what is the computer science behind blockchain, what are the different protocols we use. Then how do we write a blockchain code, right? The blockchain code is called a smart contract. Okay. Now the word says smart and contract. It is smart in nature and it is a contract obligation. Okay. Whatever you have written inside that particular code. Now, smart contracts, they run on blockchain. They are immutable because the moment you complete all your development and you deploy this particular smart contract, there is a bytecode which has been generated of this smart contract. And this bytecode cannot be edited. That is the immutability of that smart contract. It determines the computation because it has all the contractual rules. It tells where to go, from which step to go. For example, if I say that I'm logging into a particular application and there are multiple applications which needs to be logged in behind the scene when I put my username and password, the smart contract can make a smart decision saying that which application to be unlocked for you by that particular transaction. Censorship resistance, that is, you cannot tamper with it. It is, you cannot censor it, saying that, you know what, person A will be able to run it, person B will be able to run it. The moment you deploy it, everybody will be able to run it. And it can control your blockchain asset, because blockchain assets can be controlled only by smart contract, because this is the bytecode which will decide what will happen to blockchain assets. Now, when I say blockchain assets, it's a transaction. Okay, it can be a token, it can be a transaction, or it can be a data which has been sent by one party to another party, and that is called as a blockchain assets. Here are some of the programming languages which I have listed. We have Node.js, we have Solidity, we have Go, we have Java. There are other languages which are also supported, like JavaScript, TypeScript. Okay, it depends on which blockchain platform you are using. Now, when I say which blockchain platform you are using, there are two types of blockchain platforms which are available in the market. We have public and we have private blockchain. And the private blockchain is also called as an enterprise blockchain. Now, here are some of the logos which I have put out here, and you can see the majority is of Hyperledger, right? So Hyperledger is a broader umbrella under which there are multiple blockchain projects which are being incorporated. For example, Fabric is a blockchain project. Okay. We have Hyperledger Celo, which is an orchestration tool for Fabric network. We have Caliper, which benchmarks your workloads on the network. We have Hyperledger Indy, which is an identity application for Hyperledger products. Now we have three more extra out here. This is the Ethereum. Ethereum is a public network. We have Polygon. Polygon is again L2 on Ethereum. Ethereum is called as an L1 because it's a layer 1 technology. L2 is a layer 2 technology. Okay, again based on Ethereum. Okay, which is again, it has two components. You have public as well as the private network for it. And the last, not the least, that is R3 Corda. Okay, this is a private network. Okay, this is mainly focused on the financial institutes. Now, when I say public blockchain, it's public in nature. Okay, it's open, anybody can participate. Now, when I say public, that means I need to pay some incentives to the person or to the organization or to the network who is running the entire infrastructure. Just take an example. When we buy a new car, we pay road tax. Road are not been built by us, right? They are built by government. It is for public transportation. But we pay tax so that we can run our vehicle on that particular road. Similarly, when you want to commit any transactions on this public network, we pay something called as transaction fees. Now it is censorship resistance because nobody can say that, you know what, person A should not be allowed to do anything on this particular network, person B should not be. So you cannot censor anybody. It's a censorship resistance. It creates tokens, right? Because it's a public network, it is anonymized. That means nobody knows who are you. So how do you access this particular network? You access this network based on your tokens, which are being created and given to your account. And it will work even if there is a network effect. What do I mean by this is, since it is public in nature, distributed, decentralized, right? Even if there is one network or one component of that network is down, you will be still able to access it. Why? Because everybody has the same copy. So if you are not able to find anything in a particular say place, you can query it from the other nodes in that particular network. Now coming to private or the enterprise blockchain platforms. Now when I say private, that means I will have a closed group of people, and to create a closed group of people, I need some organizations. Now, as we discussed earlier, there are 5 friends who wants to go to hill station. That means I created a consortium of those 5 people together, and they can take decisions based on their willingness, right? or based on their rules and regulations. Similarly, here also, you should be having that consortium so that you can take decisions on your transactions, okay, for commitment, for verifications and validations. Now, verified identity and administrator control. Now, since it is a closed group, I will limit it to only verified identities, right? We cannot go and just talk to a random person saying that, you know what, I'm going to hill station. Do you want to come with us, right? We don't do that. That's the closed group infrastructure. Decentralized ledger. Now, many people think that it is private blockchain. That means you are not having decentralized access. You are not having distributed access. That's not the truth. We still have decentralized ledger, but this time the decentralization is among within the group of people who come together to form this private consortium. And the last and not the least, that is the trusted single source of truth. Everybody has the same data. We call it as a golden proof of data, and everybody can verify that particular data because that is a single source of truth what they have. Okay, so these are the two types of blockchain platforms which we have currently in the market. Now, I have been saying that the consensus mechanism is very important because it is like a backbone of any blockchain platform. You can call a blockchain platform, say, secured, robust, or well to use only if their consensus model is strong. Now, proof of work. We are not going to dive into the details of proof of work because the white paper itself will take more than 1-2 hours for us to understand everything, read and understand everything. I'll try to simplify it. Now, what is proof of work? You are proving somebody that you have worked on it, correct? So imagine if I create a transaction saying that 1 + 1 is equal to 2. Okay, it is very easy transaction. People can verify it because everybody knows 1 + 1 is equal to 2. Now, if everybody knows the transaction, how do I take a decision saying that who can commit that particular transaction and get incentives from me, what I'm paying as a transaction fees, correct? Now, to do that, what I will do is with the transaction, I will attach one puzzle to it. Okay. And this puzzle is not going to be an easy puzzle. That's going to be a cryptographic puzzle. Okay. Now I will I will initiate this particular transaction, and this transaction will go to all the people who are there in that particular network. Now, whoever solves this particular transaction and finds answer to my puzzle will be awarded the bounty to commit this particular transaction. So everybody starts running their nodes. Everybody will first compute the answer, see by themselves whether that is the answer of my transaction. They will compute the solution for the puzzle what I have added. They will verify from their side, and then they will say that, you know what, I solved a puzzle. Here is your transaction. Here is the answer to that particular puzzle. And if everybody agrees that the answer given by a particular node is the correct answer, that means he is the clear winner. Okay, so it's like first come, first serve. You give the answer, whoever gives the answer first gets the authority to commit that particular transaction, and that is called as proof of work. Now, proof of stake, as you can see in the image, whoever has a bigger stake in that particular network will get authority to commit this particular transaction, and that will go in a round robin fashion. For example, if I create say a group of 10 people and everybody has invested, say somebody invested say 10,000, somebody invested 15,000, somebody invested 90,000, right? Whoever has invested higher will have more stake. Okay, the transaction committing will start from there. So first transaction he will be able to commit. Second transaction will be given to a person who has lesser than 90,000, say 80,000, and it goes in a round robin fashion. So that is called as a proof of stake. Now, one important thing out here, right? There is a lot of processing power which has been wasted, okay, or been utilized when you are working with the consensus model like proof of work, because everybody is trying to search for that solution for that particular problem what you have attached. That's the reason people don't prefer proof of work and they go to proof of stake. Okay. Now the third one, okay, there are many more, but I'm just taking the top three out here. Byzantine fault tolerance. Now take an same example of the five people coming together and deciding to go for, say, hill station. I'll just alter it a bit. Imagine there are five people or five groups of a similar organization, okay, who wants to attack on a city, and they had a full-fledged plan. They said that we are going to be at five different corners of that particular city. Everybody attacks exactly at 3 p.m. so that we have more chances of winning that particular battle. Now there is unseen condition. There is going to be a rain at 3. So the leader says, you know what, let's wait till 5. Let's not attack. And this message is passed to all the 5 people. Imagine the 2 people have not got that particular message, and 3 people who got the message, or 3 groups who got the message, they decided to rest for 2 hours. But the other 2 who did not receive that message, they directly attacked on this particular kingdom. And as usual, you know, the only 2 groups attacked and the other 3 were resting. They lost the battle, right? So that means in this scenario, what we do is we try to handle the faults. Okay, we try to handle the faults. And the similar formula what we used earlier, 2f plus 1 can be used in this case. So if I want to handle 2 faulty nodes, I will have the total of 5 nodes in the organization. So there are multiple types of consensus mechanisms, okay, which can be utilized. And these are the top 3 what we have here. Now we know what is blockchain, okay, what is the computer science behind blockchain, what are the technologies what we can use, what are types of blockchain, and what is the consensus mechanism through which we can say that we will go for blockchain 1, 2, or 3. Now, what can a blockchain do for your business? This all looks very fancy, but what can blockchain do for your business, right? What is the business value for you to utilize blockchain as a technology? The first and very important is it strengthens your security, because the data which you enter is a tamper resistance, right? What do you mean by tamper resistance? Nobody can edit, nobody can delete. There is no central authority. So there is nobody who can say that it is been hosted on my system, I will go and change it. That cannot be done. It simplifies your compliances by improving auditability. Okay. Now we run compliance mechanisms, right? Whenever we say that, okay, fine, I want to procure something or I want to buy something, there are different checks what we do, right? Now these checks are been recorded on blockchain. So it helps you to simplify your compliances, okay, whenever you are doing those activities. And there is an auditable trace of what you have done, because the data cannot be deleted, neither can be edited. Now it is a new business model, okay, because it provides you decentralized trust, right? You are not being a bottleneck, you are not being a central authority who handles everything. So you have this decentralized trust mechanism which comes in. Since there are multiple parties who are there in this ecosystem, they can validate, they can reconcile your transactions. So it is again not a bottleneck on a single party, okay, or a single admin. And it cuts the cost, okay, by eliminating the intermediaries. Now, what is intermediary, right? If I don't trust an organization, or if I don't trust a person, I always need a mediator, right? A third person to build that particular trust with both the organizations. Now, take an example. You go in a bank and you say that, you know what, I want to open a saving account, right? Now, although you are putting your fund in the bank, okay, bank does not trust you, right? They will tell you, you know what, give me your documents. I need to do a KYC for you, and then I will create an account for you. Now, this KYC documents, what bank has taken, bank never sits and does KYC for us, right? They hire the third party. Somebody will come to your doorstep. The bank officer will never come to your doorstep saying that, you know what, do you stay here, or XYZ person stays here? Is this your Aadhaar card, or is this your PAN card? Can you give me a thumb impression? This is all done by the third party, and this third party acts as a trust between the customer and the bank. And that's the reason they are called as intermediaries. And if you have a blockchain type of ecosystem where you know that the data can be added, they cannot be deleted, it cannot be terminated, you don't need a third party to build that particular trust, because whatever I have added with my digital signature. Whatever bank has received, it is received with my digital signature. I cannot deny that it's not my signature because it is cryptographically secured and calculated based on my public and private keys, which are there with me. Public, which is available for the bank. So bank knows you are the person who has done this particular record, right? So that is the intermediary part. So if you think what business values I will get, you will get a temper resistance data store. You will have the provenance and auditability of your record. You will have a decentralized distributed trust. You will have instant reconciliations. Okay. And you will eliminate the intermediaries from your organizations. Now, this all looks very fancy, but the question what arises is, do we really need a blockchain at this particular time? Right? Now, we have 5-point decision making theory. Okay. The first point says that, do you have the trusted intermediaries? Which means, do you need a third party to create that trusted environment between you and anyone else with whom you are interacting? Okay. If it is not, then you should not be using a blockchain. Okay. Do you have multiple people who are committing transactions to your network? Okay. When I say multiple people, it's like customer 1, customer 2, customer 3. Are they all committing transactions from their side? Or are you the only person who is committing a transaction? So when I say only person, suppose if I have a grocery store and I'm trying to manage my inventory, do I really need a blockchain? Because I'm the only person who is writing content to this particular ecosystem. In that case, I don't need a blockchain. Do you need a single source of truth? What do you mean by this is, if there are multiple people accessing your system, okay, and if they don't trust each other, they will still need a single source of truth, right? And they will trust the single source of truth if it is from their repository, right? So that is called as single source of truth. So do you need that single source of truth? Or you are the only person who is committing the transaction and you are the only person who is viewing that particular transaction? That means you are the sole creator and sole destructor of it, right? If that's not the case, then you need a blockchain. Do you need an auditability of the records, what you have entered so far, right? If yes, you need a blockchain. And the last and very important part, do you have a business network? Are there multiple entities who are coming together for executing transactions or communicating with each other? And if yes, then yes, you will need a blockchain. So this is the 5-point theory, what we put together, wherein to make a decision saying that, do you need a blockchain or you don't need a blockchain? Now I know that I need a blockchain, but how do I make a decision point saying that which blockchain platform to go, right? There are multiple blockchain platforms. Every alternate day, somebody forks the main branch and creates their own product. Now, how do I understand which blockchain platform I should take up, right? So as we discussed, there are 2 types of blockchains, public and private. You need to make sure which one you want to use. Do you need the data to be available for everybody in the world? It's a public blockchain. Or do you have a consortium wherein you have limited set of people coming together, a set of organizations coming together, and that's a private blockchain. That will help you to drill down your choices between the blockchain platform. Now, next is permissions. What are the different types of permission constraints or access controls you want to implement in your application? Okay. Scaling, how do you want to scale your application? Do you want to commit 1,000 transactions per second? You want to commit 10 transactions per second? What is going to be your workload when you're committing this transaction? What level of confidentiality you want? Okay. Imagine if I have a blockchain platform, I have multiple vendors from where I'm purchasing, say, some electronics, say AC. There are 2 vendors, both of them are giving me different discounts. I want a discount to be confidential between me and that particular vendor. So what type of confidentiality mechanisms you want to implement in your network also will help you to understand which platform to go for. And last, not the least, that's the security part of it. Okay, what level of security is required? Okay, do you need to have access control? Do you need to have your authorization, authentications, your data encoding, decoding? What type of security requirements your organization has? That also will help you a lot when you make a decision saying that which blockchain platform to be used. Now we know we need a blockchain and we had made a decision to use a blockchain. Now I'll just give one simple example, a real-time example of one of the use case, which is very important use case, okay, named as supply chain. Now imagine a scenario that you are a customer who goes to a market and you say that, okay, fine, I'm purchasing an imported apple. Okay. Or you are the farmer who has grown apples and you are trying to export that particular apple to say US, UK, okay, or Singapore. Now what happens? Now, when you produce this particular apple at your farm, okay, you'll make that particular entry on a blockchain. Okay, it may be a private or a permission blockchain. Okay, I'll leave the choice up to the audience. Okay, now you farmed that particular apple. Okay, now you are sending it to a packaging industry to package it well, right? Now, before arriving it to the packaging industry, the manager sitting on the counter, he will make an entry saying that, you know what, ABC firm has given me 10 cartons of apple, okay, for packaging. He puts the data on the blockchain. Nobody can edit, nobody can delete. Once the products are gone inside the packaging, they have been well packaged and sent to a store, okay, for refrigeration. Now, when he is sending it out, he again puts it on the blockchain. You know, there were 10 cartons which were given by the XYZ farm. I have packaged it into say 20 cartons, small cartons, and I have sent it to a storage. Now, storage person again, when he gets the data, he puts it a record saying that, you know what, I got say 20 cartons well packaged from the XYZ packaging industry. I'm keeping it for refrigeration. Okay. And when he sends it again to the trader, he will put that particular record on a blockchain. The trader gets it, and everybody puts record as and when they get the product and as and when they send that product to the next hub. Now, at the end of this cycle is the customer who goes and purchases this particular product. Now, if I purchase that particular apple, okay, I'm not going to purchase the entire carton. Say if I purchase even a single apple, okay, the apple will have the serial number. Okay, unlike our say drug strips, right, medical strips like Crocin or anything, they always have a serial number or a batch number. Correct. So this will have serial number or a batch number. You can just query that particular number to understand few points. Number one, is it a really apple which has been exported? Okay, or I'm being cheated by just putting a sticker on that particular apple. Second, when was this plucked? Okay, and when I'm consuming it, what is the duration of that particular time? Okay, is it safe to eat it? Is it been verified? It has been tested. Is it using any pesticides? Okay, or it's organic? This everything can be traced if all the hops put the correct information on that particular chain. Now, suppose if the customer purchases that apple and he finds it faulty, and if there is a guarantee saying that, you know what, my apples are never going to spoil. If it is, I'll give you 2 apples in return. The customer can come to the purchasing stall saying that, you know what, I have purchased this yesterday. I cut it and it's been spoiled. Can you claim my reward for it? Or can you give me a replacement for it? Correct. Now he can backtrack, he can give him the replacement, but backtrack saying that where was this originated and where it might have got spoiled, or who has a responsibility to verify that it is not going to get spoiled, because we are giving SLAs to the customer saying that if it is spoils, I'll give you double the amount what you have taken. So 1 apple to 2 apples. Right. So these are some of the use cases what you can do based on your supply chain. Okay. Now, before going to takeaways, okay, I'll take a pause, as I said earlier, and I'll see if there are any questions from the audience.
Before moving on to questions and answers,
Mhm.
a quick reminder, once you all log out of the webinar, a survey form will pop up in new window. Please take a moment to fill out the survey form. Your feedback is valuable to us. I kindly request Dinesh sir to continue session.
Sure. Okay. Now let me move to the last slide. Okay. This is a takeaway slide and what we have learned so far. So we learned a blockchain is a decentralized distributed ecosystem wherein the data is been cryptographically secured. We also cleared the myth that blockchain is not a Bitcoin is not a blockchain or blockchain is not a Bitcoin, because Bitcoin is an blockchain based cryptocurrency. We saw the two types of blockchain network, that is the public and the private network. We understand the different consensus model. We know why we say that the consensus model is a core of any blockchain network. And we also learn about, do we really need blockchain? If we need blockchain, how to make a decision point on what blockchain platform to be used and how it is to be used. Now, this is an interesting quote. I'll leave you with that particular quote. Okay, this is by William Mugare. It says the blockchain cannot be described just as a revolution. It's not just a simple revolution. It's a tsunami-like phenomena, okay, which slowly advancing and gradually it will envelop everything along its way, okay, as it progresses. Now, the reason why we are saying this is there are multiple people questioning, saying that blockchain came into existence, say, a decade before. Still, we are not able to see advance, or we are not able to see government utilizing it, right? What I will say here is the innovation and the compliance, these are two different activities. Innovation, as an innovator, our responsibility is to create something which will ease the customer or ease the user. But compliance is making sure that the customers or the users' data is secured and they don't feel or that is not been tampered with. So these are two different activities. They are going hand in hand, but there is a lot of government involvement in this ecosystem. For example, we have our digital rupee, okay, the e-rupee CBDC form, which is based on the blockchain infrastructure. There are multiple organizations in a state level who are trying to create their own blockchain based ecosystems. Like people are trying to have their land registry in a blockchain, converted to be a blockchain based technology. There are some universities who are trying to convert their certification distribution or their exam data distribution on blockchain network. So it is advancing a lot. Okay, maybe another say 1 or 2 years, and we will see a lot of advancement, a lot of government involvement in compliance activity and regulation activity, which will turn the gradually revolution to a tsunami-like phenomena in future. So with that note, I will end the session from my side. Thank you, everyone. Okay. My email ID has been given on the screen. If anybody wants to know more about what is blockchain, how to use blockchain, or you are interested in any of the platforms or clearing some doubts from your side, please drop me a mail on my email address. That's Dinesh_Rivankar@directpersistent.com. Again, thanks everyone for being with me for last 1 hour, attending this session. I hope this session has benefited you. Also, thanks to the organization for organizing this entire event and considering me as one of the resource person who could give this particular session for you. Thanks a lot.
Thank you, sir. On behalf of Bytes, I would like to thank Dinesh Rivankar for such an informative session on blockchain. I request Dinesh sir to accept our virtual memento as a token of love and respect.
Thank you.
Virtual memento is taking little time, sir. Network problem. So just a couple of minutes.
Sure. Thanks a lot.
Thank you, sir.
Thank you.
I thank all the participants for joining the Bytes Expert series. I request all of you, once log out of the webinar, a survey form will pop up in new window. Kindly take a moment to fill out the survey form. Thank you, one and all.
Thank you, Dinesh sir. It was pleasure listening to you. Very fundamentally and very clearly, you articulated the entire concepts. I'm sure it has benefited a lot of people who are here. Thank you so much, sir.
Sure. Thank you.
Thank you,
Thank
sir.
you, Bharat.